Okay, so let's start with this question, right? Okay, so raise your hand, right? Who are the most appearing character in DC and Marvel? It's easy, right? It's easy, right? Just for Marvel, it's the Spider-Man, right? And for DC, it's actually Batman, right? Okay, so second question: the most appearing female good character. So female good character, right? So you double click this one, right? So this is all of the female good character. So who is the most appearing female good character? This should be this one. Susan Storm. I I don't really know her. Anyone know her? Okay. Uh, so maybe come on, this they are, they are very strange. Okay. So how the number of high appearance neutral character varies in times. What do we want to do that? If you want to, because we are thinking about the neutral characters, right? Okay. So what we can do is we can turn this off, right? So these are all of the neutral characters, isn't it? Right? So so we can see that because we want to see the trend, right? So what we mean by trend is how the number varies in time, right? So how the appearance varies in time. It looks like there is a kind of like a downward slope, isn't it? Right? Okay. But this is not fair because the longer a guy appear, the more chance that he had the chance to appear, right? So it's not that easy to make a judgment. Anyway, okay. I just want you to experience that by using this the legend selection, by using this zoom in and zoom out capability, right? A chart could be very, very useful, right? Could be very, very useful. So as I say here, this type of interactivity is the key improvement in modern data visualization, right? Okay. When you zoom out, you can observe the global phenomenons, right? And when you zoom in, you can see the detail. You can see the every single point, right? You can see every single point. So kind of like on in the old days, when the chart is static, there's a trade-off between detail and information, right? If you want more information, the chart would become very, very crowded, right? And you will no longer see the detail, right? But now you have this interactivity. You can have conciseness as well as information reach, right? So you can have these two things together. And all you need to do is to put your chart object into ggplot. Okay. This is how easy it is. Okay? Alright. So nowadays, when we are talking about visualization, as I say, there's a term called explorative, I spell it wrong, explorative, exploratory, right? Should be the word, exploratory data analysis, EDA. Now, actually, if you map the XY coordinate, size, color, shape, and actually by using this facet panel, right? you can actually use scatter plot to compare as many as 7 attributes at a time. Okay. So scatter plot is to compare attribute, right? And you can compare as many as 7 attributes at a time in a single plot. Okay. So it's a very, very powerful tool. Especially when you have the interactivity on this chart, okay? You can explore almost anything you want to explore. And the syntax is easy, right? You simply put whatever you want to observe in the AES, right? And that's it, okay? Okay, right, so for the rest of this notebook, I just want you to, when I put things in this Ninja's Dojo, I kind of means that the code could be too complicated for you, for the beginners. Okay, I just want you to see the potential of charting, right? Okay, so don't look at the code. Let's just look at the result. So in this chart, actually, every bubble is a eye hair combination. Okay, for example, this one is brown eye, brown hair, and this one is black eye, blue hair. Hey, sorry, I think it should be. Let's see. Sorry, it's hair. It's a black hair, blue eye. Okay. And this black hair, black eye, okay? So I actually I group the character with the same outlook, with the same outlook, in one group, okay? As you can see that I kind of group by hair and eye, right? So every hair and eye color combination is represented as a bubble. Okay, the bubble size is the number of character, and the color is actually the ratio of female. Okay, size is the number of character, color is the ratio of female. Okay, and X is the ratio of bed. Okay, the X coordinate is the ratio of bed, and the Y coordinate is the ratio of death. Okay? So now you can see the relationship between appearance and good bad, and also dead alive. Okay? You see my point? Okay? So every bubble is a kind of outlook. So so in this chart, we can tell that which outlook. I mean this is the upper one is the hair, and the lower one is eye. Okay, hair, eye. So which type of people is the baddest? I mean, has the highest number of bad. Which kind of outlook has the largest number of bad guys? The large proportion, I should say that. Which kind of outlook, which kind of eye hair has the large proportion of bad? Say it louder. Brown hair, blue eye, right? Because it's this one, right? Because this axis is the ratio of bad, right? It's very clear that this one has about 40% of bad guys, right? So and which eye, which hair and eye has the largest number of death ratio. I mean, has the largest proportion of death. Other hair and blue eye, right? Okay. So now you can see the relationship, right, between hair, eye, and also their ratio of death. And so in this chart, you can also see that if you make a regression line, right, there is a trend, right? In addition to seeing this each individual group, you actually can observe a trend, right? If you do a regression line, you will see a regression line like this, right? Isn't it? Right? So what does it mean? I mean, you can observe a positive correlation, right, between the ratio of bad and the ratio of death. So what does it imply? Sorry? The question again? Okay, so we can observe a positive correlation, right, between the ratio of bad and the ratio of death, right? So what does it imply? Yeah. The more death, the more bad, and vice versa, right? So you can see not only right, you can see not only the individual characteristic, you can also observe a global trend, a global phenomenon, right? Okay, that's the beauty of chart. Okay, so as another example is here. This chart is actually a dynamic chart. You can press the play. The bubble will actually move. Okay, so now again, this each bubble is a hair eye combination. Okay, each bubble is a hair eye combination. But right now I can do the observation in each 5-year period. You can see that? Okay. So as you can see, in each period of time, it changed a lot, right? It changed a lot. And in some time you can observe some global phenomena. For example, in the periods of 1990s, you can see the slope is actually going down, right? So in 1990, for some reason, the more bad, the less death, right? Okay. For some reason, in the 1990s, the bad guys live longer than the good guys in this period of time, right? So and this period of time, you can see that the green color bubble are on the top, and the red color bubbles are on the bottom, right? What does it mean? Yeah, the male has a higher casualty, right? Isn't it? But you can only observe this phenomena in the 2000. Okay, right. See, if you want to capture this phenomenon by doing modeling, right? You need to build a very complicated model, okay, in order to like observe this phenomenon, right? So a good chart is actually much more informative than a model. I can tell you, right? If you want to see this phenomena in the model, then you need to use a very complicated model to see that, okay? But in chart, you can see it very intuitively. That is the beauty of chart, okay? Okay. So from now on, and in the next few weeks, we will keep on doing data exploration, okay? And we will rely on chart a lot. We will rely on chart a lot, okay? Now you have seen the power of chart, right? Okay, it's not just like see, this is the built-in product of R, right? And this is what ggplot 2 can do for you, okay? You see the difference, right? You see why we want to do that, isn't it, right? And before we can do this, right? Before we can do this, I will have to do group by and summary, right? Otherwise, how, the way that I can build the chart like this is because I do a group by and summary by hair and eye, isn't it? Right? So you basically use dplyr to process the data, right? And to do grouping, to do group summary, and then you can use the ggplot2 to map data visualization, isn't it? Right? Okay, so that's what we want to learn in this notebook. Okay, that's what we want to learn in this notebook. Remember that scalar plot is for comparing attributes, and you can compare a lot of attributes at a time, right? And you can present the comparison interactively. Get the point? All right, so let's move on. Okay, I think we still cannot finish all of the 3 notebooks today, but that's okay. I want to make sure that like everyone can catch up, right? Any question up to this point? Okay, if no question, let's move on to the second notebook, okay? So I do the cleanup, and then the second notebook is about bar, okay, bar plot. Now, I say that the scalar plot is to compare each row, right? But bar plot is for group comparison. Okay. Now, for example, if you want to compare the number of good, bad, and neutral character, right? You use bar plot, right? Okay. So if you want to see how the number of character change in time, you use histogram, right? These are bar plot, right? Actually, we have 3 different type of bar plot. The first type is like usual bar plot. You just want to see the count, right? You count the number of bad, count the number of good, count the number of neutral, and use the count to represent the count by the height of bar, right? This is the basic bar plot, okay? Right? in a categorical variable, you count each category, right? And then you represent the count by the height of the bar. This is the basic bar plot we are talking about. And then we have histogram, right? Now the histogram, here we have a numeric variable, right? I just say that this align is actually a categorical variable, isn't it? You only have 3 different values, right? But year is kind of like a continuous, right? It's like a numeric continuous variable. You want to count the number of continuous variable, you need to chuck it into bin, right? Because it's continuous, right? So you need to like split the entire range by bins before you can count, right? Okay, so that's histogram, right? Okay. Make it a histogram, right? And then actually there are a third kind of bar plot. It's not comparing the count. It's comparing statistics. For example, this is the casualty ratio, right? So this bar is not count. It is some kind of statistics of your interest. For example, in this chart, I want to compare the casualty ratio by sex, right? So I'm not counting the number of female characters. I'm not counting the number of male characters, right? I want to compare their casualty ratio, right? So this is another type of bar plot. So as I say, bar plot is for group comparison, and there are 3 different types of bar plot. Okay? The simplest bar plot is like this, categorical, and I count the number of each category. This is a bar plot. Now, and the second kind is still count, but they are counting the number of numeric continuous variable. That's histogram. Okay? And there the third kind of bar plot, which is not counting the number, it is actually statistics. Okay? And these 3 types of bar plot need to we use 3 different geomes on these 3 types of bar plot. Okay? Histogram use geom histogram, and this bar plot use geom bar, and for this one we use geom column. Okay, you get my point? There are 3 different types of bar plot you can build by ggplot. Okay, and they need to be built by 3 different geom. Okay, okay. Now let's see the code. Okay, again, this is still the comics data set. Okay, so let's go into Studio. Let me do. Sorry. Okay. See, let's see the code. Okay, let's see the code. Now, as you can see here, this is the code to make the histogram. Okay, this is the code to make the histogram. To do histogram, you only need to map X, right? Because the Y is the count, right? The Y is the count, right? So you only need to give it the X. You only need to give it the X, right? And Y is the count. Okay? So, and this X has to be a numeric continuous variable. right? And you would see a histogram, okay? And then if you want to do a categorical bar plot, you need to call geom bar, and the x has to be a categorical variable, okay? So these two plot, histogram, bar plot. And the third thing is called geom column. And as you can see that the geom columns is much more complicated, okay? Usually, in order to do geom column, you need to calculate the statistic, right? You need to calculate the group statistics before you can display it on a column, right? Okay. So first of all, you group the data frame by sex, right? And then you do group summary, okay? If I write this way, maybe it's easier for you to see. Okay, it's actually D, okay? You put D and group it by sex, and then do, this is the group by summary, right? So after the summary, this is the data after the summary, right? Right. After summary, each group is summarized into a row, as I told you, right? In the beginning today. So before I can do a column plot, I have to do the group summary first, okay? And then I pipe this data frame into into ggplot, and I need to specify x as well as y, okay? Because in a column plot, you need to have the x-axis, and you also need to specify the y, right? Okay, because y could be anything, right? This y could be anything, and in this case, our y is the casualty ratio, right? Okay, so column plot is to plot the group statistics. It's not the count. Okay, that's the thing that you need to remember, right? And in order to plot the column plot, you will have to specify x and y, okay? And usually you will need to calculate the y before you do the plot, okay? It's a lot easier if you want to just do a bar plot, because it's just count, right? So you don't need to do anything. You just give it the x, and you will count it for you and do the bar plot, right? Histogram, the same thing, okay? Now the way I write it, the way I make this plot is as you can see that I kind of make this three plot in a row, right? Okay, and that is this, right? If for some reason, if you want to like put three plot in a row, right? This is the way to do it, okay? I kind of align, I set the three plot into three different plot objects, right? And then I plot this three plot in one row, and I call a grid arrange to do that, okay? So in this way, you can like plot several ggplot at once, okay? So so this is like three different type of bar plot. Any question? And it's for group comparison. That's the basic spirit of bar plot. Okay. Now, the complexity of bar plot kick in when you have subgroup. Okay. Now, if I just do histogram, right? I do not have this argument, right? In this thing, right? I do not have y, right? I do not have color, but here I have one more argument in the mapping. I map the color, right? I map the color with publisher, right? So it's still a histogram, but right now in each bin, the red and green color will represent DC and marble respectively, right? Same thing is for Barbara, okay? You see that, right? So you can actually use this fill argument as the subgroup, okay? Now you might wonder, should I use color or fill, right? You can try it. You can try it. If we change this argument name from fill to color, what would happen? Let's see. If I change it to like color, okay. See, color actually is the border color, right? And fill is the filling color. So now in this case, we want to change the fill color instead of the border color. Okay. Okay, it's not too complicated, right? We in the on top of the basic bar plot, we simply use color to represent subgroup. Okay, it's quite intuitive, isn't it? Okay. Now let's do an exercise, right? Like try to make the following plot. Okay, I'm saying that if we want to make a plot like this, right? And I want to modify this code, what do I have to do? Now, if I simply do this, it would not work, right? If I simply do this, it would not work. I would like to make a chart like this. What do I need to do? Okay. First of all, I need to group by sex and also by, isn't it? Right? Because right now I need to group by sex and align, so I can use align as the color, right? And then I will need to use fill equal to, isn't it? Right? So first of all, when we do the summary, we want to summary by sex as well as align, right? So you see it here, right? And then we pipe this data frame into geom into ggplot, right? With this mapping, right? And then do a column plot. What's the problem? Misspelling, right? Yeah. See, I told you, right? Don't use the lengthy variable name. It would like get you into trouble from time to time. Okay. See, okay, so You get it, right? This is to make a column plot. And for column plot, as I told you, is to do group summary, right? And right now, your group summary is basically not only grouped by sex, but also by a line, right? Isn't it? Right? So your group summary is not only by sex, but also by a line, right? And by doing that, you will have a chart like this, okay? Now, with this command, you will see that there is a warning message. It says that summarize has a group output by sex, which means that when I do this, you can see that it's grouped by sex. See that? Because summarize only take away the very last group variable, right? So it's still grouped by sex, right? Okay, so it's kind of like a warning, right? Telling you that up to this point, the pipeline is still has a group structure, right? If you don't want to have this structure, there are two ways to do it, right? One way is to add an ungroup, right? The other way is to put a this is another way to do it. It means after the summaries, drop all of the remaining group variables. Okay, as you can see here. So the group is gone, right? The group variable is gone. Okay. So now we can do the plot without the warning. Okay, you can see that. Now, but there's a problem of this chart. Do you see that? Because right now you stack the casualty ratio together, right? I mean, let's try to let's try to answer this question. Okay. So with this chart, so what are we comparing among the subgroup? Now we have 6 subgroup, right? By sex and by a line, we have 6 subgroup. So what are we comparing? Are we comparing the number of character? No, right? We are comparing the casualty ratio, right? We are comparing the casualty ratio. But, so the second question is the casualty ratio of bad male higher than that of a bad female? Can we tell that? Yes or no? How about the other guy? How about the other people? Because right now the high of the bar represent the casualty ratio of that subgroup. Okay? So the male's casualty ratio is here, right? And the female's casualty ratio is here. So is the casualty ratio of male higher than that of female? Yes, right? You can actually compare it by that. Okay. But how about the good male and good female? Now, the bad you need to compare the high of this one and this one, right? And the good, you need to compare the high of this one and this one. And for neutral, you need to compare the high of this one and this one, isn't it? Right? It's not easy to do that, right? Because if you stack, first of all, it makes no sense to stack the casualty ratio together, right? You add the three casualty data together, what does it mean? It means nothing, right? So this is not a good layout, right? This layout is not a good layout. First of all, adding the casualty data together do not mean anything, right? Second, it's not easy to do the comparison between the subgroups, right? So the easier way to do that is to draw the picture like this, isn't it? Right? You want to draw it like this. This is female, this is male. And then the color is bad, good, and neutral, right? So you can do a comparison very easily, isn't it? Right? Okay? So when you have subgroup, you will need to consider the position, okay? You need to use position to change the layout of the graph, okay? And that is the complexity of subgroup, okay? When you have subgroup, your data structure will become something like this, right? When you have subgroup, so you have male, female, and in female you have 3 subgroup. In male you have 3 subgroup, right? Or you can see it this way: in bad you have 2 subgroup, in good you have 2 subgroup, isn't it? Right? When you have subgroup, the data structure is kind of like a contingency table, right? It's a table-like data structure. However, for ggplot cannot cope with this this type of data structure, because it need to map, column into right, into the plotting attribute. So in order to do ggplot, you cannot do table, okay? In order to do ggplot, you cannot do table, because this is the metric, and ggplot only work with data frame, okay? So first of all, to do subgraph, you will need to do a dplyr package, right? In dplyr package, we have a function called count. Remember that? This is the dplyr function. So you need to count D with align and sex, and you will produce a kind of like a data frame, right? Okay. So this is the data frame. So you can fit it, you can pipe it into the ggplot directly. You cannot do it this way, right? In this way, you cannot do it in ggplot. Okay. So dplyr and ggplot is like brother and sisters. They always use together. Okay. So you use dplyr to generate the subgroup statistics, and then after the count, you can use the count to draw the bar plot. Okay. But you have 3 ways to draw the bar plot. Okay. The first way is to stack together, right? Now this is count, right? This is count. So I count align and sex, okay? So, and this is called the stacking precision. The height of each subgroup represent the count, because I'm doing right, what is that? Because I'm doing this column plot, right? And I'm counting the n, right? Isn't it? Okay. So I have align, sex, and n, right? So I have x, I have y, right? So right now I'm using this sex as the x, right? I'm using n as the y, okay? And then I'm using align as the color, okay? Now I'm using sex as x, okay? I'm using count, the n as y, and I'm using fill, the color as align, okay? This is the mapping. But besides the mapping, there's another important argument in bar plot or column plot. is the position. As you can see, here I'm doing a L apply, okay? And by L apply, I'm applying this function to this vector, right? So the first time the function use position stack. The second time the function use the position dodge. And the third time it use the position fill, okay? So in this one L apply, I generate like 3 plot, okay? And in this plot, I'm using position stack. And in this plot, I'm using position dodge. And in this plot, I'm using position fill. Okay? The position stack is something like this. I kind of stack all of the different color together, right? And position dodge is actually I pull everyone together. It's like every subgroup has a bar, okay? Every subgroup has a bar, okay? And for fill, it's kind of similar like stack, but it actually pull the upper side into one, right? So in this 3 thing, here I can see the total number of sex, right? Because this is a subgroup of female, this is a subgroup of male, right? By stacking the subgroup within female and stacking the subgroup within male, in this chart it's easier to compare the total number of male and female, right? Okay, and in this position, it's easier to compare all of the 6 group, right? Okay, and what is this chart useful? I mean, this chart is similar to this one, except that it actually pull the height of each of this bar into 1. Okay, so it kind of like change the count into ratio. See that? You see that? Okay. So when you have subgroup, you need to take care of the position inside the, no matter this is the column or this is a bar, right? You need to put a position, and that position could be stack, dodge, or fill. When you have stack position, it kind of like stack every subgroup into the group, inside the group. So it's easier to compare the sum, right? It's easier to compare the sum in each group, right? Because it stack the subgroup of female, stack the subgroup of male. So you can compare the count of subgroup. But if for some reason you want to compare the ratio rather than the count, right? You actually can, right? As you can see that if you use the fill position, right? If you use the fill position, you basically can, the height is not the count anymore. The height is actually the ratio. You see the point? Right? So here is to compare the count, and here is to compare the ratio. Okay? And in this one, you are actually comparing each subgroup, right? So different position is used in different way. You get my point? Okay? So when you have subgroup, you need to think about this position, okay? And depends on whether you want to do what you want to emphasize. You are using different type of bar plot. This is the complexity of bar plot, right? When you have subgroup, you need to use different position within geom column or within geom bar to right? To kind of like change the foundation of comparison, right? In this position, you are comparing the total number of each group, right? Easier to compare that. And in this one, you are comparing the ratio instead of the count, okay? And for this one, you are comparing all of the subgroup, okay? So we have 3 different positions: stack, dodge, and fill. There are other positions, but they are not important, okay? This is the 3 positions that I use most, okay? So I think we are running out of time today. So maybe let's stop here, and then I want you to do some group exercise today, this week, okay? So okay, here is the unit. Here is the unit web page, right? The within the Tafang folder, you already have this folder, right? Tafang folder. There is a exploration notebook called to explore, okay? So I want you to like take a look at this notebook, okay, and try to do some exploration by using the technique that we learned today, right? Okay, just take a look at it as a reference, right? I don't want you to copy it, okay? Just take a look at it, see what is doing there, right? Some of the command you might not. For example, this mosaic plot type thing, you're not familiar. I will explain that later, right? Okay, but I just want you to like take a look at this bubble plot, right? Take a look at this bubble plot, and maybe try to use the thing that we learned today, right? In order to do this bubble plot, you need to do dplyr, right? You need to do dplyr, and you need to do ggplot, okay? I want you to like apply what we have learned today to explore the data set, okay? Get together and spend some time on this data set. Try to explore the data and put the result of your exploration into a notebook, right? And then knit the exploration notebook and upload the HTML file to here. Okay? Is that clear? Okay? Just don't copy the TF2 Explorer, right? Take a look at it, right? Use it as a reference. And use what we have learned today. Try to do some exploration on the Tafang data set. Okay. You might want to explore customer group, age group, right? You might want to explore area customer group. You might want to explore product. You might want to explore product category, right? And in order to do that, you need to use dplyr to do data aggregation, right? And then you need to use ggplot to do the visualization, okay? And show your exploration, put your exploration in a notebook and knit the notebook and upload it, okay? You get me? Okay, so that's it for today, and I'll see you next week.
对，